Alright, today's lecture is going to be about waves. So I know you've all seen waves. You've gone to Galveston, you've seen the ocean waves, you've dropped something in a pool, a bathtub, and you've seen the water ripple out. All of those are different types of waves. You've done the wave at like a sporting event where you stand up and then the wave goes all around the stadium. So all of those are different types of waves. So we're going to start this unit with talking about what is a wave, how they work, and different types of waves. Okay, so the big thing about a wave, the definition of it, is that it's a propagation of a disturbance through a medium, okay? So I know the word propagation seems weird, but really what you're talking about, propagation, is movement. So you're talking about the movement of a disturbance. So the movement of some sort of energy, of water, of sound through a medium. The term medium is just referring to a material that it can travel through. So a medium could be a solid, liquid, or gas. So when you talk, there's a sound wave that travels from your mouth through the air until it reaches someone's ear. When you're talking about like a water wave, there's all of that water that allows the wave to keep moving. Okay, so there's an example below that I want to show you. So one of the big things about this idea about the wave propagation is that the medium doesn't move with the wave. Okay, it sits there and it travels. The object itself vibrates up and down, but the object doesn't move side to side with the wave. So if you think about when you do the wave in the stadium, you go up and down, the wave travels to the person next to you, you don't move with them. So the energy moves, but the actual wave does not. The actual particles part of it do not move. So what that looks like from this video is here you have a ball that's going to move, and it sits there, and as it travels, the little ball, this could be like a buoy in the ocean. If you've been to Galveston, you've probably seen these, and it sits there and it moves up and down with it, but it doesn't move overall. The same thing happens with like a duck that's also sitting in the ocean. They're able to move up and down with the wave, but they don't sit there and all of a sudden start coming into shore. So if you notice, the particle moves up and down with the height of the wave, and then the energy transfers side to side. So the energy moves, the particle just moves up and down, the particle doesn't move completely down away from it. Okay, so that's one of the big things for you guys to see about waves, is the fact that it is the energy that's going to move. Okay, the medium is going to move, but the particle doesn't move with it. Okay, so that's the big thing. Sorry, that's a typo right there. It should say the particle does not move with the wave. Okay, sorry about that typo. Alright, so there are two types of waves. So we're going to classify waves in all different types.
Waves have energy. Whether it's sea waves.
Sorry about that. Forgot to stop the YouTube video in the background. Okay, so two types of waves that we have are mechanical and electromagnetic waves. So the mechanical waves are something that require a medium. So they're not going to move unless they have a medium. So they have to have either a solid, liquid, or gas in order to travel. So sound, for example, must have a medium to travel through. If not, you would never hear anything. So there's no sound in space. Okay, you watch all those space movies and you hear like explosions happening, and you hear like Star Wars, you hear people flying around outside. You don't actually hear that. If you watch the movie Gravity, they do a really good job with that, where with Sandra Bullock, she's sitting there in the little capsule, and all she can hear is her own breath, basically. She doesn't hear anything that's going along outside of it. All she hears is herself. The reason she can hear herself breathing is since there's air in that capsule that she's in. But other than that, there is no sound in space. So if an astronaut was outside of the space shuttle doing some work on the International Space Station and his radio went down, he would not have any way of communicating with anybody else, because he could talk and he could hear himself because there's air in his helmet, but another astronaut that's 5 feet away from him would have no idea what he was saying. You'd have to lip read. Okay, and the reason that you can lip read is because electromagnetic waves don't require a medium. So electromagnetic waves would be light waves, microwaves, X-rays, radio waves. So thank goodness for radio waves that they don't require medium. Otherwise, all of the satellites that we have orbiting Earth that allow you to be on the Wi-Fi, allow you to have cell service, your LTE, satellite TV. So all of those things are emitting signals from outer space into Earth. So if those waves required a medium, your cell phone wouldn't work, your internet wouldn't work, and your TV wouldn't work either. So be thankful that they don't. The other important reason about electromagnetic waves not needing a medium is that if they did, there would be no sunlight. Okay, so light comes from the sun, it travels through empty space, literally like a vacuum where there's nothing, there's no particles or anything, and then the light reaches Earth. So be thankful that we have it, so that way we can actually see and be warmed up by the sun. Otherwise this planet wouldn't exist. Okay, the next way that we can describe waves is through pulse or periodic. Okay, so a pulse wave is a wave that just consists of a single traveling pulse. So it just goes up. So if you imagine like taking a slinky or a jump rope and you just move your arm once, okay, that would be a pulse wave. It's just one wave that travels around. A periodic wave is when it's that constant motion. So if you ever did jump rope and you sat there and you moved your arm over and over and over and over and over and over again, that's what you call a periodic wave. Okay, so a periodic wave is something that goes on constantly. You could think of it like a clock, like a grandfather clock. It sits there and swings back and forth and back and forth and back and forth. Okay, so again, I have a little demo to show you what those looks like. So what you have here is, it's a PhET simulation. I know we've seen these before. So I want to show you a pulse wave first. So I can use the pulse wave, and if you notice, it's just one single part of a wave that's moving, and it moves up and down along the string. If you notice that the particles themselves move up or down, but they don't actually move side to side. So that goes back to that idea about the medium and what moves. Okay, the energy moves, the particles themselves just move up and down. So they just sit there and they go up and down, and then they go back to where they originally were. If I restart it and you want to see a periodic wave where you have that constant motion, it would look like this. So you'll notice that the machine on the left is constantly moving, constantly adding energy to the system, and the system goes crazy. Okay, the particles are still only moving up and down, but they're just moving up and down with a lot more energy because you're constantly moving. This would be like the person that takes a slinky and keeps shaking it up and down, up and down, up and down, up and down, a whole bunch of times. Okay, I'm going to restart that before it goes crazy here even more. Okay, so those are two of the ways that we can describe waves. So you can have a electromagnetic or a mechanical wave, or you can have a pulse wave or a periodic wave.